Alright, so I'm going to do a video on limits. It's probably, in my opinion, one of the hardest parts of Calc 1, just because, you go into it and you're fresh from earlier math courses, and, you kind of stick to algebra and such, and you don't really get into, like, the weird stuff, as in, like, the Greek letters and such. So I'm going to try and simplify it to make you understand it a lot easier. So, in limits, you're basically playing a game. So, if we have a line like this, and we have an equation, x over square root of x plus 1 minus 1, what we're saying is when x is 1, when x is 0, you get plus 1 minus 1, so you have 0 over 0 when x equals 0. So in an actual graph, at x is 0, you have a hole in the graph. And what we're doing with limits is we're saying, okay, well, we're going to find out what this hole, what the number would be if it was there. We're going to approximate what it should be. So by doing that, the easiest way to do it is to find the left and right of it. And if we find out what the left and right is, we can approximate what the middle should be. And we do this by using limits. So we can say the limit as x approaches 0 on the right side. So we do a plus on the right side to say the right side, and the limit as x approaches 0 on the left side. And on the right side, we could pick an arbitrarily small number, like a really small number, on the right side of 0. So we could put 0.0001 over square root of 0.0001 plus 1 minus 1. And on the left side, we could put negative 0.0001 over square root of negative 0.0001 plus 1 minus 1. And you get two answers. For the right side, you get about 2.0005. On the left side, you get about 1.99995. So just by looking at this, we could say, well, it should be about 2. And this is basically what we're going to do, but we're going to make it a lot more solid, the understanding of it, by using a formal definition that was made by some guy a long time ago, and it's called the Epsilon delta proof. And what this says is, I'm going to move this over. I'll move this over way over here. And what this says is that on a graph, we're going to find for point CL, we can call this CL, point CL, we're going to find a number right above it, like how we did here, number right below it, and we're going to call this number epsilon. So we're going to say, okay, well, above it, we're going to say L plus epsilon, because it's epsilon above, and we're just saying epsilon is equal to some really, really small number. 0, 0, 0. Well, you can say whatever you want to epsilon be. Right here, epsilon was, if you solve for y, that's what you get epsilon for. So you can say y equals, and epsilon would be 2.0005 and 1.9999995. Whichever number we got, that's what epsilon is going to be. So it's going to be the other side of this. So we're going to say e plus epsilon, e minus epsilon. So it's going to be these 2 points, boom, boom. And underneath it, we're going to have our x's. And our x's was 0.001 and negative 0.001. And that's going to be our x's. So, and we're going to call these x's, of course it's c, we call it cx. So we're going to say c minus delta for the left side, and c plus delta for the right side. And epsilon delta basically is arbitrary numbers in which we'll find exactly what the points are. So the idea is that we by giving an epsilon or delta, we could find what the approximate number would be. So basically, as x approaches c, so we're going to use this the limit as x approaches c, based off of this, or on this side it's x approaches 0, so x approaches c, f of x becomes arbitrarily close to L. So f of x becomes extremely close to right here as x approaches c. So, so basically what we did here is that we have f of x right here, and as we got really close to 0, we found these numbers, 1.999 and 2.005. So as we approach c, we found L right here. So yeah, so that's what we're doing right here, and we have these two equations. So if you move things around, you get about f of x minus L is less than epsilon, the absolute value. So that means that you have f of x equals L plus E and L minus E. So if you subtract L on both sides, you get this, and then absolute value because you have minus plus. So that's what absolute value does. It gives you make the epsilon positive, but you turn this absolute value. So then we have the same thing for over here. So you have 0 less than x minus c, absolute value less than delta, and this is still on the left and right side, and you just move it over and you have a minus and plus. So that's why you have absolute value. So this is the definition of limits, which is super hard to understand, so you have to do a lot of practice with this. But I'm going to use this to solve a quick problem. So so the problem is that we are given a delta. We have to find a delta given an epsilon, which means that if we are given on this graph, if we're given this E above and below, this part right here, we have to find the deltas that go with each E, which is sounds complicated, but it's really not. So for this problem, it says the limit as x approaches c 3 of 2x minus 5 equals 1, and they want to find a delta such that absolute value of 2x minus 5, which is a f minus 1, because they solved it, is less than 0.001. Is less than 0.1. And what this says is basically we want to find these deltas when E is 0.01 and negative 0.01, because that's the value. So how do we do this? So we're going to oh, sorry, I'm not finished. And the problem ends up with whenever 0 is less than x minus 3. That's kind of a big part that we needed. So basically, it's saying that whenever at this part is 3, x equals 3 if you add 3 on both sides. So at x equals 3, what's the delta on both sides when we're added 0.01 to the epsilons? So what we're going to do is we're going to try to figure out how to work with this problem. So you have 2x minus 5 minus 1 absolute value, is less than 0.01. And by solving this, you get 2x minus 6 is less than 0.01. And if you factor out a 3, you get 3x minus 3. Factor out a 2. You get 2x minus 3 less than 0.01. This is still absolute value. And what happens is, if you divide by 2, you get x minus 3 less than 0.0005. What this says is that the deltas is going to be to the left negative 0.0005 and to the right 0.0005. Which, so basically it's kind of playing a game where you give me something, I give you something else, you give me something, I give you something else, and just by working it out you end up with, you could solve for what epsilon and delta would be. That's going to be my video on limits. I'll do some more problems when you're at school and then you have some problems with school and such. So